Now, why does this matter? So now let's talk about net filtration pressure. Again, this is very similar to the net filtration pressure we talked about with the capillaries. So net filtration pressure is a number, and the pressure is determined on it's either positive, negative, or zero, and it has a number attached to it. So net filtration pressure, how do you calculate it? And this is why I have the shirt on. We have math today. So glomerular hydrostatic pressure minus capsule hydrostatic pressure minus blood colloid osmotic pressure. So it is similar to the net filtration pressure we had earlier, but now we have this capsular hydrostatic pressure. So the thing is that compared to, why didn't we have that third number in the previous example with the peripheral capillaries, is that usually interstitial fluid pressure is near zero, but capsular hydrostatic pressure is usually significant. That's why we have to consider it. But what we have here, well, remember that net filtration pressure and peripheral capillaries, this was moving water from a capillary into the surrounding space. Same principle here. So net filtration pressure, filtration is going from blood outside of the blood and pushing out from the blood vessel into the surroundings. So when you have positive net filtration pressure, that means the filtrate is being moved into the capsule. If you have negative, that means the filtrate is moving back into the blood. So that means that you're taking what is supposed to eventually become urine and putting it back in your blood. That's why in normal, healthy, functioning kidneys, you should have a positive net filtration pressure, because again, your kidneys are trying to take your blood and filter out waste particles it doesn't need. Okay, so basically, if it's going the same direction, it's going to add to net filtration pressure. So glomerular hydrostatic pressure is moving in the right direction, therefore it's going to add to net filtration pressure. But capsular hydrostatic pressure and blood colloid osmotic pressure, even though you should always have this in your capillaries, they are going the opposite direction, and that's why you subtract them from glomerular hydrostatic pressure, because they're moving in the wrong direction. All right, so then example here, what if you have a glomerular hydrostatic pressure of 60 millimeters mercury, and then you have a capsular hydrostatic pressure of 10 millimeters mercury and a blood colloid osmotic pressure of 30 millimeters mercury? Can you calculate your net filtration pressure? And yes, you can. So again, what you do is just plug in the numbers. So 60 minus 10, because again, it's going in the wrong direction. And then 30 minus 30, because it's going back into the capillaries. So what do? Just subtract these numbers. So 60 minus 10 is 50. 50 minus 30 is 20, right? So 20 is our net filtration pressure, and more specifically, positive 20. So what we have is an overall pressure of 20 millimeters mercury moving fluid from the capillaries into the surrounding capsule. Yep, and someone got the correct calculation. So positive NFP. So now the filtrate is moving from the capillary, that glomerulus, into the surrounding capsule. And then what we have here is that what we have here is a different example. So our glomerular hydrostatic pressure, or GHP, is 20 in this example. And then our capsular hydrostatic pressure is the same, 10 millimeters mercury. But our BCOP is 40. And say this person's a little dehydrated. What is our net filtration pressure? Well, this person actually has a very low GHP to begin with. So what it is negative 30. Yep, 20 minus 10, 10, and 10 minus 40 is negative 30. Because it's negative, which way is the fluid going to go? Yep, it's because it's negative, these two forces are going to win out. So because you have 50 over here and 20 over here, this is going to force fluid back into the capillaries, which is not the direction we want to go. So negative NFP, filtrate is going to move overall from the capsule into the capillary. So we're not getting filtration overall from our glomerulus into the surrounding tissues.